This video will revise on the calculations part of electrolytic cell. Before we look at the calculations, we shall revise on the Faraday's first law of electrolysis. So Faraday's first law of electrolysis is defined as the amount of substance produced at each electrode is directly proportional to the electrical charge flowing in the cell. So from the definition, we can see that to do the calculation, there are two things at least we need to calculate. First is the amount of electrical charge flowing in the cell. Second is the amount of substance produced at each of the electrode. From Faraday's first law of electrolysis, we can see that problem solving for electrolytic cell basically involves three steps. The first one is to calculate the amount of charge flowing in the circuit Q, and the second one is to calculate the number of moles of products produced at each of the electrode. Then, using the number of moles, we can convert it to mass or volume, depends on the questions. So now I'm going to use the example question to explain how to calculate Q, how to calculate number of moles, and to use the number of moles to convert it to volume as required by this question. So in step 1, calculate Q. So how to calculate Q? Basically just need to use the formula Q equals to IT. Must remember the I here is current in ampere and the T here is time in second. So in these questions given in hours, must remember you need to convert it to second later on. Sometimes when calculating Q, the questions might want it in terms of number of Faradays or number of electrons. So what do we need to do? Basically what we need to do is we use the equivalent 96,500 Coulomb equivalent to 1 Faradays or 96,500 Coulomb equivalent to 1 moles of electrons to convert it to number of Faradays or number of electrons. So for these questions, we don't need to do the conversions, we can just leave it in terms of Coulomb. So how to calculate the Q? Just apply the formula Q equals to IT and substitute in the 2.5 amperes current and 3 hours must convert it to second and then multiply together, then we can get our Q, which is equivalent to 27,000 Coulomb. So step number 2 is to calculate the number of moles. Before we can calculate the number of moles, we must first write the half equation at anode or cathode first. Then use the equivalence from the balanced half equation to calculate the number of moles. Like for this question, it's asking you to calculate the volume of oxygen gas collected. Remember, oxygen gas is collected at anode. Hence, for this question, you just need to write the half equation at anode and then use the balanced half equation to calculate the number of moles of oxygen gas. But for revision purposes, I will discuss the products formed for both cathode and anode based on this question. So before looking at what is being produced at cathode and anode, we shall look at the electrolyte first. For this question, our electrolyte is aqueous solutions of copper 2 sulfate. So means that the species present will be copper 2 plus ion, sulfate ion, and also water. So in electrolytic cell, cathode is negatively charged, hence it will attract cation, copper 2 plus ion, and water. Copper 2 plus ion has more positive SRP value, hence it will be chosen to undergo reduction at cathode to produce copper solid. So the half equation, therefore, at cathode will be copper 2 plus ion receive 2 moles of electron to produce copper solid, and the observations at cathode therefore will be brown solid deposited at cathode, and the brown solid is actually the copper solid. And for the anode in the electrolytic cell is positively charged, hence it will attract anion, sulfate ion, and also water. Water will be chosen to undergo oxidation at anode to form oxygen gas. Why? Because sulfur in sulfate ion has achieved highest oxidation state, +6, and therefore cannot oxidize further. And hence, sulfate ion cannot be chosen to undergo oxidation at anode. And water will be chosen to undergo oxidation at anode to form oxygen gas. And the half equation will be 2 moles of water oxidized to form 1 mole of oxygen gas, and also 4 moles of hydrogen ion and 4 moles of electrons. Then we can use the equivalence from the balanced half equations at anode to calculate the number of oxygens formed. So in this balanced half equation, 4 moles of electron is being produced, and this is equivalent to 4 Faraday and also equivalent to 4 times 96,500 coulomb of charge, and this is also equivalent to 1 moles of oxygens. Remember, in step 1, we calculate our Q in terms of coulomb. Hence, we choose 4 times 96,500 coulomb equivalent to 1 moles of oxygens as the equivalence. And then remember, in step 1, we calculated our Q is 27,000 coulomb. And by comparing it with the equivalence, this is equals to 0.06995 moles of oxygens produced. So step number 3 is to calculate the volume or the mass, depends on the question. Like for this question, it's asking about volume of oxygen gas. So means that we are calculating the volume of gas. So to calculate the volume of gas, we just need to use the formula. Still remember the formula to calculate the volume of gas? It is number of moles equals the volume of gas divided by the molar volume. And the molar volume depends on the condition. So for STP, it is 22.4 dm³ per mole, and at RTP is 24 dm³ per mole. And for this question, it is asking at STP, so means that we are using 22.4 dm³ per mole. So, and then what we need to do is to substitute the number of moles we calculated in step 2 and also the molar volume at STP into the formula, and then we get the volume of our oxygen gas as 1.57 dm³. So one thing to take note is, remember at the beginning I told you that to solve calculations problems for electrolytic cell, it will require you to do the 3 steps: calculate the Q, calculate the number of moles, and then calculate mass or volume, depends on the question. Must remember, for these 3 steps, it might not always be in sequence. Again, not always in sequence. So means that not necessary to calculate Q first, then calculate N, then calculate mass or volume. It can be from given the mass or volume, you calculate number of moles first, okay, and then only you use the equivalence, okay, like what you do writing the half equation to determine the Q, okay, and then from the Q you determine what is the current or the time. That's it, the revisions on electrolytic cell. To enhance your understanding, you might want to try the questions given and check your answer. Thank you.